I'm Wink Allison. I'm a forage agronomist with the LSU Ag Center, and I'm going to talk to you today a little bit about liming pastures or liming forage crops. We're going to talk about soil acidity, liming materials, and what they do and that sort of thing, and then we'll get more into specifically about pastures and things like that. Now, I'm sure that almost all of you realize that the reason you put lime out in an agricultural situation is to neutralize acidity in the soil, and to raise the pH, which is neutralizing acidity. Now, pH is nothing more than a measure of the hydrogen ion concentration in the soil. And as pH goes down, acidity goes up. It's a logarithmic thing, but it's a negative log. And don't worry too much about that. That's above my head also as far as logs and stuff. But it just means since it's negative, when the pH goes down, the acidity is going up and things. So now there are sort of two types of acidity in the soil. You'll see a lot on soil tests when they refer to active acidity. That is just a measure of the hydrogen ions that are actually in solution in that soil. And then there's something you'll see sometimes called buffering acidity, or the buffer pH. And what that's referring to is hydrogen ions that are not in solution, but they are adhere to the soil particles, just like most any other cation. A soil particle has a charge, and these cations are attracted to it. So they'll just adhere to it, just kind of like a magnet you can think of. So once you take hydrogen ions out of solution, it changes the concentration, and some of the ions that are adhered on the soil particle will let go and come into solution. So that soil has a capacity to buffer itself to maintain that pH. And so when you're liming, you've got to address the active acidity and also the buffering acidity of that soil. And that's why you could send in two soil samples from two different fields, and one of them and both of them have a pH of say 5.6, and it tell you that you need to add 1 ton of lime on one field to get the pH to 6.0, and on the other field it says you need to add 2 tons of lime to get the pH to 6.0, because the second soil would have more hydrogen ions adhering to the soil particles. So it has a higher buffering acidity, and you've got to correct that as well as just that active acidity. And this has a lot to do with soil textures. Clay soils that have more clay in them tend to going to have a higher buffering capacity than those that have more sand or silt and things. So there's you're going to see different things. Just because you have a certain pH doesn't mean you add a certain amount of lime and it's always going to change it the same way. So a soil test is necessary to figure out how much lime you've got to put out there. Now, what are the sort of liming materials that we use? Most all limes that are used in an agricultural situation are going to be a calcium or magnesium oxide or carbonate, hydroxide or a silicate, something like that. And a lot of people think that it's the calcium and magnesium that's actually responsible for the change in pH, but that's not actually the case. I've had people call that say, I don't understand this. My soil sample shows that my calcium level is high, but my pH is low. And how is that? How can that be? Well, that is because the calcium and the magnesium have a pretty minor role to play as far as the pH is concerned. It's actually the carbonate or the silicate or the oxide or hydroxide that actually reacts with the hydrogen ion to neutralize it. So it just happens to be that calcium and magnesium are generally with those in natural settings is where we get lime. Now, what is lime? It's typically, or that we use in ag or ag lime, it's typically either calcitic or dolomitic limestone, which is a sedimentary rock, and they dig it and they grind it up. They grind it so that it passes, you know, a certain mesh screen, and so much passes a 50 mesh and some an 8 mesh and things like that. When I say mesh, you can think about the screen on your window. It's got a mesh, but it's the 50 and the 8 are just referring to how many holes are in a square inch or a certain area or something like that. So, but you don't have to worry about that when you buy lime, because the State Fertilizer Commission has regulations that any liming material sold in the state has to have a certain percentage that'll pass X screen and a certain percentage that's this other screen and things like that. So it's regulated to do that, and you're going to get a liming material that meets those state regulations. All right, now talking about why the material needs to be ground up, just to give sort of a visual idea, think about if I went out and I took a block of limestone that weighed a ton and I set it out in the middle of an acre, I just applied a ton of lime per acre. But now how much acidity am I going to neutralize with that? In very little, because the only place it's touching any soil acidity is right under that block. The other 100-foot radius all around it that's part of that acre is not touching anything at all. So it needs to be ground up fairly fine, and the better it's ground, that way you can spread it across the acre better and get better coverage, because it's only going to react when it reaches some type of acidity. So you need it ground up fine enough to cover that acre. Also, I have seen at times an estimate of where limestone, and not, this is a fact, I mean limestone is not real soluble in water. I mean, if you took a limestone and put it in water, it would just be a rock sitting in water. It's not going to dissolve very readily. So you grind it up to help break it down, but it also gives it more surface area so that the acidity or acid can cover more area and react with that calcitic limestone or dolomitic limestone and all. So now that you've got it out there, what's going to happen is you're going to, if you get rainfall and you get it in the soil a little bit, then it comes in contact with acid, and it's going to split that molecule, and the calcium will go off, and then the carbonate, say, reacts with the acid, and it forms. You get calcium plus carbon dioxide plus water. Well, water is H2O, so you just took 2 hydrogen ions out of solution, combined them with oxygen, and formed water. So they're no longer active as a acid forming compound or acid measurable in that soil solution. So basically that's how you are reducing acidity, is you're just combining that hydrogen with oxygen in a way. Now, soil acidity is all through that profile. When you take that soil sample and you go to 6 inches depth, you're measuring acidity in that 6 inches. Now, if you put lime right on the surface of the soil, it's not going to come in contact with a lot of acidity at the time and things. So it's better if you can incorporate that lime and mix it into the soil so that it's touching more particles that may have acidity, and it will work faster. And some of this is why they talk about lime. You need to be applying it months ahead of time and things like that, especially in row crops and things where they are doing some tillage. Now, obviously, in pastures, that's not always going to be an option. I mean, the warm season grass or perennial warm season grass pastures, we're not out disking them every year, and we can't mix lime and things like that. So you really have no other choice but to surface apply that lime and things. But in looking at the forages that we grow, I mean, our warm season perennial grasses, Bermuda, Bahia, Dallas grass that's out there, you're probably not going to get a real measurable response if the pH is at least 5.5 or better than that. So it's not like we're having to maintain that higher pH for those grasses and things. Now, the cool season grasses, the annual cool seasons we use, ryegrass, wheat, oats, those type things, there is information out that shows they probably respond a little more to liming if the pH is less than about 5.7, 5.6. So they're a little more sensitive to that pH than our warm season perennial grasses. Now, if you're using a legume, you obviously need to get the pH closer to 6, or between 6 and 6.5 is kind of the ideal point there. That's ideal for the plant as well as the chemicals in the soil. Probably a lot of you have seen that all these soil chemicals are not equally available at all the different pHs. So a lot of times we talk about the ideal being 6, 6.5, and that's in regard to the efficiency of the nutrients that are in the soil. And since legumes tend to have a taproot, they don't explore the soil quite as much as grasses. They're going to be a little more susceptible to lower pH and things, and also in our soils we'll have free aluminum ions, and the lower the pH, the more of those that are in the soil. When you raise the pH to about 6, these things are precipitated out. They're not biologically available, and they're not going to harm the plant. Now, what the free aluminum does is it messes with the cell membrane, plant cell membranes. So if you've got a lot of aluminum there, you're going to have restricted root growth just because it can't, the cell membranes or become too permeable and things. So you need to lime for that, for a chemical reason as well. Now, knowing that our crops or our forages, the grasses, tend to not require a real high pH, is not a reason not to be concerned about liming, because a lot of our soils can go down below 5. I've seen a lot of soil tests with pH below 5. So you need to be conscious of when you're actually approaching that sort of critical pH level, and do something with your lime or liming prior to getting to that point. Because as I said earlier, this limestone is not real soluble in water, and if you put it on the surface, it's going to take possibly 2 to 3 years to actually move down through that profile and all. So if you wait till you reach that critical 5.5 level before you lime, for 2 or 3 years, that lower part of that soil is going to continue to drop in pH before you get that liming material down there. So it's not like those are values you're looking for to get to and then lime. You want to lime before you get to that point to keep that plant actively growing.